In this assessment, we're asked to tell what functional groups might be present based on the spectrum shown. Now, it turns out we have a little more information than just the spectrum. For example, we have the molecular formula. And that molecular formula is going to allow us to calculate an index of hydrogen deficiency. For C3H4O, that index of hydrogen deficiency is going to be 2. And so when we look at the spectrum, we're going to be looking for things like that represent pi bonds. So maybe a carbon-oxygen pi bond in a ketone or an aldehyde, an alkene or an alkyne. Now, the first thing that jumps out is this really broad band around 3,300. That's going to be indicative of an alcohol. So this molecule probably has an alcohol functional group based on that band. Now, since that takes our oxygen and makes it part of the alcohol, now we know there's probably not a carbon-oxygen double bond, no ketone or no aldehyde. So all of our index of hydrogen deficiency has to be wrapped up in the carbons, either as 2 pi bonds or a pi bond and a ring. I guess possibly 2 rings, but with C3, that's going to be hard to do. Luckily, our spectrum tells us this right away, because right around 2000 here, we have this band, this kind of sharp band. That number at 2000 tells us that we have a carbon-carbon triple bond, or suggests a carbon-carbon triple bond, which would use up both of the index of hydrogen deficiency. So in addition to having the spectrum that we can look at, we also have the molecular formula that can allow us to make our guess that the 2 functional groups that's present are the hydroxyl group and the alkyne.